Alright, let's play around with that equation for the maximum speed of an oscillator. So we have a 50 gram mass, and it's attached to a spring that happens to have a spring constant of 4 newtons per meter, so a very weak spring. So it's going to oscillate this mass with an amplitude of 1.12 meters. Let's find the maximum speed of the oscillator. So first off, I don't like that mass being in grams. We're going to convert that to kilos. So we're going to have this 0.0500 kilos. Newtons per meter is fine. Meters is fine. So we'd like to find the maximum speed of the oscillator. Now, you are not given V max equals A times the square root of K over M. Again, we're going to get that using this EP max equals EK max. So EP max is going to be our half KX squared, X max, and then this EK is going to be our half MV max squared. So again, those halves can take a hike. We don't need them. Now, do you need to change X max to A? No, you can leave it as X max. It's your call, and in fact, I'm going to do that. So I'm going to say that V max squared is going to be KX max squared divided by M, and then of course we can square root both sides. So we get V max equals KX max squared over M. Do you have to bring out the x squared to the front? Nope. If you don't want to simplify this, this is fine. We simplify it for presentation purposes. To actually calculate it, you do not need to simplify it. This will work fine. So the maximum speed of this oscillator. So we have this spring constant of 4 newtons per meter. We're going to multiply it by this amplitude and square it. And then we're going to divide this by a mass of 0.0500 kilograms. And then we'll square root that lovely thing. Don't forget the square root. That is what gets people on these questions all the time. So don't fall victim to that one, please. So this oscillator is going to travel with a nice speed of 10 meters per second, or at least that is its maximum speed. So it's going to start out 0 at the amplitude. It's going to make its way to equilibrium. Once it hits equilibrium, it's going to travel at 10 meters per second. It's going to slow down to 0 for it to reach the amplitude. And it's just going to continue bouncing back and forth between the amplitudes. All right, last one here. So I'm going to set up an oscillating horizontal mass spring system. Spring constant of 6.05 newtons per meter. Maximum displacement is 81.7 centimeters. So this is an amplitude. And we don't like centimeters. Let's put that in meters, 0.817 meters. And a maximum speed of 2.05 meters per second. Let's find the mass of this oscillator. So this time, let's see what we got going on. So we have our EP max, or EK max, is equal to EP max. So we're going to have half MV max squared is equal to half KX max squared. Again, the halves, we're going to take a hike. So I'm going to have MV max squared is equal to KX max squared. Great. My interest here is in finding the mass of the oscillator. So let's divide both sides by V max squared. Again, don't forget the square, really important. So what we're going to find is for this oscillator, its mass is going to be KX max squared divided by V max squared. So the last thing to do is to actually calculate this thing. Don't forget the squares. That is the big thing that is going to get people on this. So we have a spring constant, where is that, of 6.05 newtons per meter. And then we have a displacement, maximum displacement of 81.7 centimeters, or 0.817 meters. Do not forget to convert that, and don't forget to square it. And then the maximum speed we're told is 2.05 meters per second. Also don't forget to square that. So lots of places to fall victim to the traps. Don't do it though. You're smarter than that. I trust in you. Alright, so we do that. We are going to get about 0.961 kilos. So this oscillator, oscillating about this point, based on the information we have, it's going to have a mass of about 0.961 kilograms. So that's the main thing with these maximum speed questions. If you don't want to memorize that V max equals A times square root K over M, that's just a mess, and that's going to make things really hard for you. If you can remember that EP max equals EK max, then you can derive it from scratch, and you don't even have to simplify it to the extent that we've done it. That's the key for these questions.